particle is projected with speed u at angle alpha to the horizontal. So velocity vector is u cos alpha in the I direction plus u sine alpha in the j. This is this classic question that gets asked quite a lot. So we're looking for the max value of r. The value of alpha, well, we know that's 45 degrees. We've done so many of these. So if we draw a little sketch of my projectile, I've got max height, I've got the range, and I've got my projected speed in this direction. So if we want to find the time taken to get here, the displacement in the j direction or the y direction is equal to 0. So ut, u sine alpha by t plus a half at squared, so that's minus g over 2 by t squared, has to be equal to 0. And if we factor out t, we get u sine a minus gt over 2 equals 0. So this is my initial time of 0, and then we're going to get a u sine a will be equal to gt over 2, so multiply by 2 and divide by g. That's the time taken. And displacement in the x direction or the I direction is equal to ut. There's no acceleration. So u cos alpha times 2u sine alpha over g is going to be equal to the range. So we're going to get u squared, and we're going to get 2 sine a cos a, and that's all over g. We need this in just terms of sine or cos, and 2 sine a cos a is sine 2a, so we're going to get u squared over g sine 2a is equal to the range, and we want the max range, so if this is equal to 0, we're going to get, we're asked to use calculus, so we need to differentiate. So we have to differentiate the angle, just going to write or there, going to differentiate the angle with respect to the range. So the ADR will be equal to u squared over g, sine 2a becomes cos 2a, and differentiate the angle, we get 2. And then the max range will be when this is equal to 0. So this means that cos 2a will have to equal to 0. The cos of 90 is 0, so 2a is equal to 90. So a is 45 degrees. Then we're told if the range is this guy, find 2 possible values of a. So we have to let u squared over 2g, that's the range, equal what we have for the range, which is u squared over g sine 2a. So if we divide by u squared over g, we'll end up with 1 over 2 is equal to sine 2a. And the sine of 30 is a half, and 150. So my 2a will be equal to 30 and 150. A will be 15 and 75 degrees. Then we're told the ratio of the max height to the range is 2 to 5. So our range, which we've already worked out, is 2u squared sine a cos a. I think that's what we need here, over g. And then to get the max height, on our little sketch again, at the point here, our max height, we can either have velocity being 0, or we can say the time taken to get there is half the total time. And the original time that we got was 2u sine a over g, so 2u sine a over g divided by 2 would just give me u sine a over g. So we want the displacement in the j direction at this time. So the displacement in the j direction, u sine a is the initial velocity, ut, t is u sine a over g, minus a half at squared, so minus g over 2 by this guy squared, u squared sine squared alpha over g squared. And if we tidy this up, we're going to get u squared sine squared alpha over g minus the g and the squared will cancel. We're going to get u squared sine squared alpha over 2g. So it's like we have a full one and a half of one, so we're just going to end up with a half of one. So it's just going to be u squared sine squared alpha over 2. That's going to be the height. The range is 2u squared sine a cos a over g. So if the max height to the range is 5 times bigger, so I need to multiply the height by 5 and the range by 2, and then they're equal. So we have a lot of things that we can cancel. We can cancel u squared, we can multiply by g, we can divide by sine a, that will cancel that one and the squared part. So what am I going to be left with? I'll be left with 5 sine a over 2 is equal to 4 cos a. Sine over cos is tan, so sine a over cos a is equal to 4 times 2, which is 8 divided by the 5. So tan a is equal to 5. Sorry, 8 over 5. So that will give me a to be the inverse tan of 1.6. A is giving me 58 degrees here for the angle. And then the last part asks us the kinetic energy of the particle that's measured at the instant it's fired and again at the instant just before it lands. So the symmetry of our curve. So they measured here and exactly the same point over here. What would we expect the kinetic energy to increase, decrease, or stay the same? At these equal points here, we would expect the kinetic energy to be the same.